Hello children, I am Bindu. Today I am going to teach you the chapter Sound of Physical Science of grade 8. This is the second part of sound. Before going to the second part, we shall revise the part 1. Sound propagates through medium, and the medium can be solid, liquid or gas. Sound is produced by the vibration of the particles of a medium. A sound is a form of energy that is transferred as vibrations through the air or any other medium in the form of waves. The distance between two consecutive particles which are in the same phase of vibration is called wavelength. Frequency is the number of vibrations of a particle in the medium in 1 second. The speed of sound is the distance travelled by sound in 1 second. The speed of sound depends on the properties of the medium through which it travels, like temperature, pressure and humidity. Sound cannot propagate through a vacuum. After the completion of this lesson, students will be able to learn sound wave, characteristics of wave motion, types of mechanical wave, properties of sound, definition of amplitude, type of sounds. Keywords to remember: mechanical wave, particle, loudness, amplitude, frequency, hertz, pitch, timbre, audible, infrasonic, ultrasonic. This is the mind map of sound. Hello children, we are already aware of energy, and the amazing thing is that the sound which we listen in our daily life, that is also a form of energy. It is transferred through the air or any other medium in the form of mechanical waves. A mechanical wave is a disturbance. Disturbance? Yes, disturbance. Here, disturbance means the randomness of particles that make the wave altogether. All the particles propagate in a medium due to the repeated periodic motion of the particles of the medium from their main position. The disturbance which is caused by the vibrations of the particles is passed over to the next particle. It means that the energy is transferred from one particle to another as a wave motion. Now, we shall know about the characteristics of wave motion. In wave motion, only the energy is transferred, not the particles. The velocity of the wave motion is different from the velocity of the vibrating particle. For the propagation of a mechanical wave, the medium must possess the properties of inertia, elasticity, uniform density, and minimum friction among the particles. Till now, you have already got to know about the mechanical wave. The real-life examples of mechanical waves are watching or seeing something and listening to sound. But both of them are not the same. There are two types of mechanical waves. They are transverse wave, longitudinal wave. Have you ever thought in your mind, how can we see anything with our eyes? While you are watching or seeing something, the particles of the medium vibrate in a direction which is perpendicular to the direction of propagation of the wave. This is called a transverse wave. Example: waves in strings, light waves, etc. Transverse waves are produced only in solids and liquids. Longitudinal wave. In a longitudinal wave, the particles of the medium vibrate in a direction which is parallel to the direction of propagation of the wave. Example: waves in springs, sound waves in a medium. Longitudinal waves are produced in solids, liquids, and also in gases. Now we shall read properties of sound. All sounds that we hear are not the same. There are some properties like loudness, pitch, quality or timbre, and audibility that differentiate one kind of sound from another. We will study these properties now. The first property is loudness. Loudness can be defined as the characteristic of a sound that enables us to distinguish a weak or feeble sound from a loud sound. The loudness of a sound depends on its amplitude. Amplitude? New word. What is amplitude? Amplitude is the maximum displacement of a vibrating particle from its main position. It is denoted by A. The unit of amplitude is meter. Do you know what is the relation between amplitude and loudness? The higher the amplitude, louder will be the sound, and vice versa. When a drum is softly beaten, a weak sound is produced. However, when it is beaten strongly, a loud sound is produced. The unit of the loudness of sound is decibel. The second characteristic of sound is pitch. The pitch is the characteristic of sound that enables us to distinguish between a flat sound and a shrill sound. The higher the frequency of sound, the higher will be the pitch. High pitch adds shrillness to a sound. The sounds produced by a whistle, a bell, a flute, a violin are high-pitched sounds. Now I am telling you one real-life fact. Normally, the voice of female has a higher pitch than a male. That is why a female's voice is shriller than a male's voice. Some examples of low-pitched sounds are the roar of a lion and the beating of a drum. Next property is quality or timbre. The quality or timbre is the characteristic of sound that enables us to distinguish between two sounds that have the same pitch and amplitude. For example, in an orchestra, the sounds produced by some musical instruments may have the same pitch and loudness. Yet, you can distinctly identify the sound produced by each instrument. The fourth or last property of sound is audibility and range. There are many sounds surrounding us. Some of them we can hear, some of them we cannot. But all sounds have a frequency. According to the frequency, we can classify the sounds into three types. They are audible sound, infrasonic sound, ultrasonic sound. Now we shall read audible sound. The audible means that we, a human, can hear. Sound with frequency ranging from 20 Hz to 20,000 Hz is called sonic sound or audible sound. Sound with this frequency range alone can be heard by human beings. Human ears cannot hear sounds with frequencies below 20 Hz or above 20,000 Hz. So, the above range is called an audible range of sound. Next is the infrasonic sound. A sound with the frequency below 20 Hz is called subsonic or infrasonic sound. Humans cannot hear the sound of this frequency, but some animals like dogs, dolphins, etc. can hear. Uses of infrasonic sound are: it is employed in the Earth monitoring system. It is also used in the study of the mechanism of the human heart. The third one is ultrasonic sound. A sound with a frequency greater than 20,000 Hz is called an ultrasonic sound. Animals such as bats, dogs, dolphins, etc. are able to hear certain ultrasonic sounds as well. Some of the uses of ultrasonic sounds are: it is extensively used in medical applications like sonogram. It is used in the sonar system to detect the depth of the sea and to detect enemy submarines. It is also employed in dishwashers. Another important application of ultrasound is the Galton's whistle. This whistle is inaudible to the human ear, but it can be heard by dogs. It is used to train the dogs for investigations. A bat can hear the sounds of frequencies higher than 20,000 Hz. Bats produce ultrasonic sounds during screaming. These ultrasonic waves help them to locate their way and the prey. Summary of the lesson. The larger the amplitude of the vibration, the louder the sound. The higher the frequency of vibration, the higher the pitch, and the shriller is the sound. Sound is produced by vibrating objects. Sound travels through a medium like gas, liquid, or solid. It cannot travel in a vacuum. The higher the frequency of sound, the higher will be the pitch. Music is produced by the regular patterns of vibrations. Sound with a frequency ranging from 20 Hz to 20,000 Hz is called sonic sound or audible sound. A sound with a frequency below 20 Hz is called as subsonic or infrasonic sound. A sound with a frequency greater than 20,000 Hz is called as ultrasonic sound.